Grade 12 Science, this is number 8 of the 2014 exemplar paper. A very good question, and I just want to work through this. The voltaic cell represented below functions at standard conditions. Now let's always remember what that means. There's going to be a question about that. Now in this reaction, slightly different from what we used to, we have two graphite electrodes, and then we have an iodine layer in the bottom of this beaker, and then the permanganate solution that we have here. So it is quite a different setup. Then they say write down the concentration of H plus in the 1/2 cell. Now H plus in that half cell, we will always have 1 mole per cubic decimeter. The next question, solids present in half cells are usually used as electrodes. Give a reason why iodine solid is not suitable to be used as an electrode. Now remember that iodine, being a solid, is a diatomic solid. There's no free electrons in it. So therefore it will not be used as an electrode because it is not a conductor. Write down two properties of graphite other than being a solid that makes it suitable for use as electrodes in the above voltaic cell. Now the reason why we use graphite, and the same reason why we use platinum in the gas electrodes, is that graphite, first of all, is a conductor, opposing the iodine, which was not a conductor. So it is a conductor, and then it is an inert solid. That means, that word, please remember that word, inert. It does not react with anything. Same with the platinum. Then for the above voltaic cell, write down the name of the oxidizing agent. Now always, when you do these questions, identify your redox by using your half reaction list. So on this list, we are going to look for our oxidizing agent and reducing agent. Now, if you look at your table, you see the iodine half reaction is here, and then the other one that you need to find is your permanganate. Now, permanganate is always a strong oxidizing agent, so there's your permanganate reaction. Then put your finger on the two substances, move the bottom finger always to the left so that you have a line, I always say, with a positive gradient between these two. If you then keep your finger on, your H2O2 on that side of the table will be the reducing agent. So write that in, which will be oxidized, and the other one on the left-hand side of the table will be the oxidizing agent. So the MnO4 minus is your oxidizing agent. Therefore, we can start to write down the name of the oxidizing agent. Now, name means you must write it out. You can't just copy the formula. So that will be the permanganate ion, permanganate. The net cell reaction, so that is now where you need to do a little bit of work. The oxidation half reaction will be the top one of the two that we have identified. So it is the 2I minus going to I2 plus 2 electrons, and the reduction is the bottom one of the two, will be that one, the MnO4 minus plus H plus 5 electrons going to Mn 2 plus 4 waters. We then need to balance the electrons, so we will have to multiply the top one with 5 and the bottom one with 2. That will be 10 and 5 and 10, and then the bottom one with 2, so it's 16, 10, 2, 8. The electrons can now be cancelled, and nothing else can be cancelled, so it will be 10I minus. You simply add what's on the left hand side, plus 2MnO4 minus plus 16H plus 5I2 plus 2Mn2 plus 8 waters. It's always a good thing to just put in your phases, because you're going to need the phases in the cell notation and the water liquid. Right, the next question is to give the cell notation. Now, this is a very important question. Now remember, the structure of cell notations is always anode, salt bridge, cathode. Then at the anode, oxidation takes place. So you start with which substance is oxidized. It is the H2O2. The I minus that is oxidized to form I2. So it's going to be I minus, just shift this up. It's the I minus that will be oxidized to I2, then salt bridge. Then it was the MnO4 minus that was reduced to Mn2 plus. Now you put a solid line between substances that appear in different phases, and that was the I minus that formed the I2 solid, and it was the MnO4 minus aqueous, and there was an H plus, so it's comma when it's in the same phase, and another comma because Mn2 plus is also aqueous, and then there's a line because what we actually have here is the graphite electrodes. So remember that it's solid, and it also needs to appear in this side, so it's carbon solid. So very important just to go over. We have the solid carbon, the graphite, line because we have different phases. It's I minus aqueous. Then it's a line because it is different phases again. But this was your oxidation. And then salt bridge, and after that the substance that will be reduced. So it's the MnO4 minus aqueous, comma, H plus because it's acidified and it is part of the half reaction, comma, Mn2 plus aqueous. Line, carbon, solid. Always put a line when you have a change in phase. Calculate the cell potential of the above cell. Now there you just always start with your formula. So it's the E reduction. Important that you never abbreviate anything in your formula. You must write it down as it is on the formula sheet, and you read the values off. So it's the 1,51 minus 0,54, and you get 0,97 volt. If this value works out to be negative, then you know there's a mistake. You need to go back because you can't have a negative value for a spontaneous reaction. Then they ask, how will the reading on the voltmeter be affected if the concentration of the MnO4 minus decreases? How will the voltmeter reading be affected? Now, if you look at your reaction here, the forward reaction, which is going to produce this energy, giving us the positive voltage, is the formation of the Mn2 plus. Now, if you then decrease the amount of MnO4 minus, so this is a Le Chatelier equilibrium question. If you decrease the concentration of the permanganate ion, the reaction will be forced to the left. The equilibrium will shift to the left, and that will not favor the forward reaction, so the voltage will decrease. Thank you. That's all for number 8.